Dr. Emil Kendziorra worked for several years in cancer research. He then became entrepreneur in medical companies. He's currently CEO of Tomorrow Bio and the president of board of the European Biostasis Foundation. Both are organizations that help bring possibility of cryonics to the people of Europe. I'm very happy, Emil, to have you here.
Well, welcome everybody. So I'm of course going to talk about what I would call a longevity moonshot, cryopreservation, sometimes called cryonics or biostasis. My background is, as I was briefly introduced, I studied medicine a very long time ago. This is me here, like 18 years ago, here in the blue tie. In my early, I think this was my early, probably it was 19 or 20 or so. I went into medical school to go into longevity. So longevity has for a very, very long time been my focus. And then, as I just was introduced, since then I've been running a few tech companies, not because I wanted to run tech companies, because I never found something where I felt like it has a high impact on longevity. When I say high impact, I mean living healthy is great. But once people live healthy, and of course, this is already kind of happening with compression of morbidity and so on, then I would always argue, at least in my personal view, then I would also like to live longer. Right? And of course, as most of you might know, this is not really happening. You have these morbidity curves where over the last couple of decades and centuries even, the older people get, the more and more people make it to the age of 50, make it to the age of 60, make it to the age of 70. Right? These curves here are from the 1900s to 2020. But even though more people make it to, let's say, 70 and are healthier than they were in the past, everybody still dies somewhere between 85 and 95. So with all the great longevity stuff that has been discussed and of course over the last couple of years has kind of picked up, we have not extended the maximum lifespans in humans by even 1 year. So I'm not arguing, of course, that there is no progress being made. I'm arguing that between what predictions we're making and what turns out to be true, there's a big difference. And so, of course, since I come from cancer research, a lot of my examples are always from cancer research. The most prominent one, I think that I feel like that is most illustrative, is that in 2005, the National Cancer Institute in the US, the biggest cancer research institute there is, had a goal that they wanted to achieve in 10 years, in 2015. Right? And that goal was to get rid of cancer, to eliminate cancer, period. Not make it better, but eliminate it. Right? And a lot of cancer associations back then signed on to that goal. And of course, 2015 is now, 10 years ago. Cancer is still the second leading cause of death. And between 2015 and now, we spent around 500 billion in inflation-adjusted money on cancer research. So I think there is much too high a probability that all of you, and me included, are going to be 85 at some point. We're going to be healthy. We just came back from a hiking trip or a golf trip or a sailing trip or whatever you like to do, with your friends. And then a doctor tells you that you have 6 months to live because your maximum lifespan has not been extended. So this was never something that I really wanted to do. So since I didn't really find anything where I feel like, okay, there's a good chance that will extend maximum lifespan, I've decided to work on this. The thing that from science fiction movies, where you cryopreserve, of course, colloquially sometimes called freezing people, and then once in the future medical technology will have advanced enough, you might have the chance to bring these people back. But whenever I talk to journalists, it's always called freezing, right? This was a BBC article, and you see this picture that is kind of like a frozen window. Of course, everything we do is not freezing, it is cryopreservation. And I'm going to tell you in a second of how this exactly works and what we're doing and how we're set up. And even though my example just now was an 85-year-old, right? Like who's dying at the end of their life, or at least the end of their current life. Usually the people who get cryopreserved, they're not that old. They're actually quite young. This was one of our last people that have been cryopreserved with us. Someone living in Madrid, married, had some children, and just had the unlucky event of getting pancreatic cancer relatively early in their 50s, in their mid-50s. Right. And then unfortunately it was metastasized. And then the doctors told them, you have a couple of months to live. But whatever we do, like we can take the pain away, but there's nothing that we can do to save your life. And this is quite common. These are the ages of the people that are in cryopreservation with us now. And the number, this is a bit outdated. There's a couple more now. And there are some old people, 99, 90, 85, but there's also a tremendous amount of young people, in their 50s, even in their 20s, or in their 30s that just have, like an unlucky event where they get some disease early that just with current technology we cannot cure yet. And then these people, unfortunately, currently have the choice to say, I want to be either cremated or buried. And in my worldview, right, there is no coming back from that. If you get cremated, that's it. You're gone forever. Or, even though there's a lot of questions open for cryopreservation, and I'm of course happy to answer all your questions that you might have in the end, the only alternative to cremation or burial that these people can choose is to say, okay, I'd rather be cryopreserved. I'd rather be cryopreserved and take the chance that in the future, my cancer or whatever it is curable. And there's actually a lot of people who want to do this. So we designed like large studies, which are now also published in a couple of journals. We did it in Germany, in the US, recently in Switzerland, where we asked people like, how long do you want to live? And, is cryopreservation something that you would consider? And first of all, a tremendous amount of people would like to live significantly longer than currently possible. 26% here say, I would like to live indefinitely. And as I said, there's currently 0 drugs, 0 treatments that extend maximum lifespan at all. And then depending on how you ask, around 20 to 30% of people say, if my choice is between cryopreservation and cremation or burial, I choose cryopreservation. Now, what is cryopreservation, right? Again, colloquially, it's always called freezing, but it's not that. In fact, it is quite the opposite to freezing. This is a very famous picture from one of our research partner labs in the US, where here on the left side, you see a frozen kidney. This is all at negative 140 degrees Celsius. Right? If that frozen kidney, if you, this is just the kidney, you put it into, well, in this case, negative 140, all the ice freezes. And then if you would warm up that kidney, it would be mush. It doesn't work anymore. All the cells, are dead. The cells have holes, ice crystal damage everywhere, and so on. But on the right side, there's a cryopreserved kidney, or in another word, a vitrified kidney. Vitrified basically means putting it into a glass-like state. So if you cryopreserve something, you put it into this glass-like state, right? And you can already see this kidney looks significantly more how a kidney is supposed to look, right? And if you warm that kidney up, and in fact that was done here, and you transplant it back into the animal, in this case a rabbit, but this was later replicated recently, in fact, in a Nature paper in rats as well. Then the kidney works, the animal survives, However long the kidney would have been in cryopreservation, you can basically maintain it there indefinitely, and it fully still works. So what we're doing is doing that vitrification procedure, that cryopreservation procedure, with whole humans. Not just with organs, but with whole humans. On one hand, that's a research project. But on the other hand, this is something that we actively do, right? Because if someone gets cancer today, it does not matter what type of great research results we might have in 10 years. right? If you have terminal cancer today and the doctors tell you that you have 6 months to live, then again, if there's the greatest treatment in the world in 5 years or 10 years in the future, it does not matter because you're already going to be buried and cremated. So while we actively work on the research side of cryopreservation, we also offer it as a service for people after, of course, very comprehensive informed consent, who say, I'd rather be cryopreserved than cremated. This is one of the long-term cryopreservation storage rooms in our facility in Switzerland. This is underground, and you see these very large-scale, on the right side, the stainless steel capsule. It's a so-called dewar. It's a very, very well insulated, hard vacuum insulated, large, kind of vessel with liquid nitrogen in there. Doesn't need energy. It's purely passive. You just need to refill the liquid nitrogen. And then inside, it has a temperature of at least negative 140 degrees, usually negative 196 degrees Celsius, at which temperature these cryopreserved people can be kept pretty much indefinitely. It does not matter if this is 10 years or 20 years or 50 years or 100 years or 200 years, whatever the time frame needs to be, it does not matter. Right? Because when you currently go into cryopreservation, we don't know yet when diseases will be curable. We don't know yet when it will be possible to live longer. And in fact, we also don't know yet when it will be possible to reverse the procedure of cryopreservation. The only strong statement I'm willing to make is that cremation or burial gives you a 0% chance to be back in the future. Cryopreservation at least is better than zero. Right? And this is what we do here in these large-scale dewars. This is the research facility. It's a bit north of the Zurich airport. The room that you just saw is underground behind that building. There's a lab, of course, as I said, lots of research being done. We host conferences there. In fact, next weekend there's a scientific conference at the facility. We have an operation room and an imaging facility with CT scanners to do quality assurance of people in cryopreservation, and so on and so on. Basically, do this procedure from A to Z, and at the same time continue to research it. And apart from that, we also have medical teams, right? So cryopreservations need to be done very quickly after your heart stops, right? Because of course, once your heart stops, the cells start degrading, right? And if you wait too long, then it might the probability of you being brought back and revived in the future, of course, goes down significantly. This is one of our teams here based in Switzerland. We have these mobile operating rooms. Basically, we buy ambulances, and then our engineering teams, they retrofit these ambulances to be mobile operating rooms to do a whole cryo protection procedure here on site in these ambulances. And in fact, by now we have them all over Europe. So we have our headquarters in Berlin, in Germany. We also have them in Zurich. We're building them with local partners in a range of different countries in Europe, in the Netherlands, in Spain, in France, and so on. And with these locations, we cover currently all of Europe. And since recently, we also have teams in the US. Now we have in New York, in California, and in Florida. We have these ambulances with medical teams as well. And we are building another one in Texas and another one in Portland, in Oregon, to then be able to comprehensively cover the US as well. Now, technically, we cover the whole world, but we only allow people to sign up with us as long as they either live in Europe or in the US. The reason for that being is that you need to be quick with how fast you do the cryopreservation. So we always want to make sure that that there's no delays. And of course, if we would have someone who wants to be cryopreserved in, let's say, I don't know, South Korea or in South Africa or wherever, or Brazil, I don't know, somewhere around the world, then we would not be able to do that procedure with high quality because we would be far away. But of course, if someone signs up with us in Europe and then dies somewhere abroad, we would still cover them, for example, if they die on vacation or whatever, right? And with a multitude of different organizations, again, we're pushing a lot of research forward with 21st Century Medicine in the US, CryoDAO is an organization that we set up to fund research in that space, with Oxford Cryotechnology in the UK, with Advanced Neural Biosciences in the US as well, and so on and so on. And of course, when you talk about cryopreservation, the most important point is the brain, right? Everything that makes you, as much as we currently understand, is in the brain, right? Everything that makes me, memories, identity, personality, everything we care about. So whenever we do one of these cryopreservations, we do basically a quality assurance CT scan after depreservation, basically to check if the cryopreservation was in fact a cryopreservation and not just freezing someone, right? Freezing someone would mean there's ice crystals everywhere. These ice crystals would destroy the cells and so on. So this is one of our CT scans here. Of course, normally CT scans are in black and white. So this is in so-called pseudo color. It basically colors all the areas in green that have received enough cryoprotective agent to not have ice crystals form there. There are some of these regions like here that are yellow, but these regions are ventricles and the dural sinus, so regions of the brain that are filled with fluids where you don't have brain tissue. So not important that those are also preserved. Right. So if someone says, "Hey, listen, I want to do this," you can do this today, right? This is kind of like a unique field of it is a research project and it is something that people can do today. Unfortunately, it is still relatively expensive. So if you want to be cryopreserved today, unfortunately, since very few people do this, it's on the tune of 200,000 euros to do whole body cryopreservation. But of course, we have large life insurance partners where those costs are funded through life insurance contracts and so on. So it is affordable to most people who say, "I want to do this." So I'm, of course, happy to answer any questions now. But if anybody says, "Hey, listen, I really want to dig deep and I have a lot of detailed questions here that might be out of scope for this short talk today," feel free to reach out to me. I'm always happy to chat. And of course, cryopreservation is has very much become my life and probably will be my life for the next couple of decades. But unfortunately, I don't see any high probability on the horizon that the longevity field will be able to extend maximum lifespan anytime soon, which is kind of supported by the fact that a lot of the CEOs of the large longevity companies are customers with us. I have my fingers crossed, but if not, then at least I want to make sure that I get a very good cryopreservation and then have a chance. Even though I can't tell you how high that chance is, again, I'm very confident in saying it is higher than cremation. Feel free to reach out, and otherwise, I'm more than happy to answer any question that you might have now.
Thank you, Emil. Thank you for your speech. Now we have questions. Yes, the first question.
What I'm interested, what is your opinion on why we haven't reached cancer-free society by this 2015? What is the problem? But not only in the cancer research, any degenerative disease is staying still in one spot. So this is of my interest, rather than to be cryopreserved. Can we move this 500 billions? Let me say this again. So the money is not the issue here. What is the issue? Is it intellect? Is motivation? Is administration or bureaucracy? Whatever. I would like to hear your opinion.
Yeah, I don't know for sure, of course, but so when I was in academia and doing cancer research, I think there's a couple of reasons that why this is. First of all, biology is really hard, right? So everything, of course, and of course, people who work in the lab here know everything is like super indirect. It's very difficult to get direct measurements. Clinical trials are extremely expensive, so putting anything and trying it in humans is very tough. There is, of course, a bit of an add-on effect that a lot of researchers, and of course, part of that money went to academia. Impact points doesn't necessarily mean impact. right? And so, of course, a lot of money is maybe not spent in the best way, but I have no idea of how I would do this better, right? I think in the end, it comes down that biology and figuring out how to get rid of these very complex diseases like cancer, and of course, cancer is more a group of diseases than a single disease. It's just like the complexity seems to be just too high for our current understanding of how biology works to figure it out. So don't get me wrong. I think we will figure this out at some point, right? Cryopreservation is not a solution. Cryopreservation is a stopgap measure. It's a bridge. It's a bridge that might allow us to get to a time, where these things are cured. So I don't know I don't think there's a single reason. I think it's just really, really hard. It's not because people are not motivated. It's not because of people are not intelligent. It's just hard. And I hope I'm wrong. I hope, that when I'm 85, there is great longevity medicine, but I don't want to count on it. Like, I still have my fingers crossed, right? But, I just want to make damn sure that if I'm 85 and I'm dying, that I can get a great cryopreservation instead of, a great cremation. So that's why I'm personally have said, okay, I'll work on that.
Thank you, Emil. We have 3 more questions.
So if I understood correctly, they managed to cryopreserve a kidney of a rabbit and then transplant it. Is that correct?
Yes.
Has anything like that been done with other organs? And if so, what is currently preventing us from restarting the whole body?
Yeah, so basically cryopreservation is a function, or how well you can cryopreserve something is pretty much a function of size. So very small things are very easy to cryopreserve, right? I mean, everybody who works in a lab has cryopreserved cells, pretty much every day almost, maybe, right? For in vitro fertilization, you can cryopreserve egg cells. You can cryopreserve small organs. You can cryopreserve C. elegans, the small worm. The problem is that if to do cryopreservations well, you need to be able to cool down very fast, and you need to be able to warm up very fast, and you need to do that uniform, right? And now, just from a thermodynamic standpoint, if you have a large volume, then the surface area of that volume grows slower than the volume, right? So basically, you have the problem that if you have a large volume, like a human organ or a whole human, then they have a bad ratio of surface area to a volume. So basically, if you try to warm up like let's say a human kidney or a human liver, if you try to warm it up fast, the outside is already too warm and the inside is still a clump of ice. Right. So the reason, or one additional reasons why I like to work on cryopreservation more, directionally, of course, I'm exaggerating a bit, but directionally, the problems in cryopreservation are physics problems and less so biology problems, which is usually a bit easier. So short answer, the speed of warming up and cooling down in large volumes, which human kidneys would already count as large volumes, is very difficult to do. And in fact, currently not possible.
Thank you. We have time for 2 quick questions. So please.
Hello, Emil. What was the biggest organism which was successfully taught and survived?
So from cryogenic temperatures, C. elegans. So very small. C. elegans can be cryopreserved and can be brought back. It keeps its memories in quotation marks. I mean, it's C. elegans. It's a worm memory, so it's not maybe directly comparable, but of course it is memory. And it reproduces and so on. From lower temperatures, there's like a couple of things that can go to -20 or so, but they do it in a different way. So from a cryopreservation standpoint, the largest that currently is possible, C. elegans.
Okay, thank you very much. The second question was the same. So we have it. So thank you very much, Emil. We are very happy that you spoke about cryonics, which is very important for longevity. And now we go to the next speaker.
Thank you so much. Bye-bye.
Thank you.